An alternative frame configuration would be flipped upside down, in which case the offset, I probably gain another 2 inches there, or lose another 2 inches rather, for a lower center of gravity. But the trick is that's going to start making things tight with my lower member of my mast, and now I have a limited amount of clearance to work with. Even from the center line of the pin, you're still losing another ½ inch or so. I really don't want this plastic piece to be the lowest thing on the whole thing. So I guess that's not going to be able to be mounted on the bottom. I'm going to have to figure out how to mount that a little bit up because I want something solid to be the lowest point in case I run into anything. I like the lower center of gravity. I think I'm starting to bind my own wrists with how low it's getting and not having enough room to work though. If you're going for a possible motor mount, you just add a piece of the square tubing, and that bait is loose, like a Loctite it. This one, I could Loctite it into there. And you can see the motor has its wiggle room. And we can also do a torque test to see how much, like I'm pushing pretty hard on there, and I'm not able to stall it, so I think that those motors will be adequate. I don't like that. And I don't like that mount. Flexible couplings are so expensive. So here's a thought on a possible linkage to keep the motor from rotating and being able to transmit the torque to the tires. Basically, it's just like a linkage, and so the nut cinches it up against the plate. That way, all of the studs are tied together through this. And I'm not just operating on just one, which would be a bad idea. The thing is I'd have to drill the holes tighter. See, a hind joint is a good idea. I like it. I would do it. Except it's going to be like $30 for 4 of them because they're not cheap, right? And the Lovejoy couplers, that's not a bad idea either. That's probably the better way to go. Except either one of those things I have to order and wait a couple days to come in. I don't even think any of them were prime, so there was nowhere local to carry them. I drove all over the place. So I'm just kind of playing with alternatives. I think this would work if I drill tighter holes. I don't want, every time I go from forward to reverse, I'd hear it clunkety clunk 4 times over, so that's not acceptable. And so the next motor has even a little more wobble than the first one. So this one I just bolted tight, and that doesn't allow it to have the wiggle. So for quick projects, I think that this, a single linkage doing it would be adequate for, a lot of types of projects. For this one in particular, I went ahead and ordered some of the flexible couplings. I ordered 3 different types because there weren't 4 in stock of any one type. Yay. And so I'll play around with them and see if I like those any better. I might as well. This will get me through, and also it's hard to control the positioning with a single linkage like this, especially without anything adjustable. At least this is minimum invasive, and it doesn't hurt the frame or anything. And it'll keep my motors roughly in position while I work on the mast until the parts arrive, because it's a weekend and I can't get anything for several days, so good enough for now. Alright, so next order of business is setting final mast height and distance. We're going to attach it to the frame. Before we can attach it to the frame, we happen to know what kind of connections we're going to do to the bottom for the 2 actuators. So the next logical step is to beef up this bottom cross member. And I've put in a couple attachment points for the 2 actuators and start to get an idea of what that looks like. And to do this right without going too far out, I might have to take a chunk out of my frame for the actuator. Alright, so to beef up the bottom member, we're going to double it up and use a piece of this hot rolled, which is, I think, much stronger than this. This bent metal is basically sheet metal, which is it's like an easy flow, it's very bendable. It has to be easily deformed because they're doing it in a pressing operation. So that stuff is always more flexy than something like this, had a hot roll. So we'll double that up. So next I need a way to, so my linear actuator is 10 inches and I need a way to transmit the power from this base, to the top of this linear actuator. So how do I transmit the power? And outside of this front cross number as well. So I think that will do the trick. And I want to keep this as compact as possible because everything I add to this keeps spacing it, all over those front wheels. It becomes a leverage issue. So I think something like that, or it'll be down about here. So, I think that'll work out. I'd already tested and made sure I do actually have over 6 inches of travel. I have like 6.5 inches of travel on the carriage, so we're always going to be within range of this without hitting anything. Now we need to start working on a mount for our 2 linear actuators, and here's kind of a rough design of what I came up with. They will set about like so, somewhere like that. That will give me just enough spacing to be off the back of this by about 1/4 of an inch. Those two, as they rotate, will never touch, and I'm not too incredibly high up. Also, so a lump cardboard moffett, and the 3 things about it is it's really cheap material. So, your first one might not be right, and you could get a rough idea with the first one. Try and just start playing around with it. You can see that I ended up moving my center for the pothole 3 times because, I wasn't thinking about this extra distance and stuff. And then here, I was a little too close to the edge, so, you just said, well, I'll learn. Takes a couple tries, no shame in that. All right, so we're going ahead and we're cutting out a couple of these brackets out of probably 1/4 inch. I could do a lot of sawzalling and grinding, but to cut out a shape like this, I have a plasma cutter, kind of a cheap one. I bought the Lotus, it was like $500, but I can cut out pieces really nice. So figured I'd give it a shot. So my first thing, I did it by hand, freehand. Man, it's ugly. It's super ugly. And I missed my scribe marks, and I was even holding a bright light right over it because of shade 7. I cannot see. It drives my trays out. I don't do it very often, but so you might have seen this before. There's a whole video on this. It's a plasma tracer, basically. So you cut out a wood template, you trace around it with a stylus that has a point, so you don't really have to offset a diameter, and then you can cut your piece on the other side. So that gives me a much nicer piece, as you can see. So even though my only flaw in this plan is that I hate having to drag this out of the basement and set it up because I don't have any floor space, they'll just leave it set up. I wish I did. But, come shop, make do with what you can. So cut out another one of these, and that'll keep going. To go back over by hand in a couple little places, but repeatability is good, much nicer than, that would have taken a lot of cleanup and a couple more cuts. I don't know, 6 of one, half dozen of the other. I like the repeatability and the framelessness. You could just push it against the template and go. Chipped off any slag, gave them a rough grind on the bench grinder. You can see the shapes actually came out really close. Tacked them together, ground where they're going to register against the frame so that they sit exactly in the same way when they're together. And then I could drill both sets of holes when they're together. And then if I wanted to clean up that anymore, this would be the time to do it. But I think I'm just going to free them and welcome to the fine now. So we clamp and space everything to the right width, so we know the holes are aligned. And then we just did some light tacks just to get its initial position. I'm not going to weld that solid until we actually connect up the actuator and know that the carriage moves smoothly all the way up and down and that I don't have to change anything. So I added a couple spacers down below so that at its lowest retraction, which I actually didn't test to make sure I was at my lowest retraction. Let's hope that I played with it, and I did, because that'll be offered. The danger would be is that my bearing could crunch into my weld, and we don't want that. So I'll leave the bumpers in there just in case. That would be pretty awkward. It's only tacked, don't worry. So then we made sure we were parallel. Then I put in a bunch of spacers and taped it to maintain my parallelism. Then I used some gussets and what I did was I kind of marked it through there with a scribe. I just kind of reached in with a long, sharp, pokey thing and just kind of traced the circle when I was at the right spacing. Then I welded these two together, drilled the hole, freed them, tacked them, and now we added a couple spacers up here so that everything was right. It looks like this is a pretty strong setup, actually. Like that should be adequate. So this is how she looks all the way up. So we're 20 inches from the very bottom to the very top, and our crawl space is 24 inches high, but the ground might have some variations, so I'd want to leave like at least 2 inches, although I am probably going to rake it out just so it's nicer, you know. So let's say that I want at least 2 inches of clearance. So I have 4 to work with, so this would only be 2 inches off the ground, which is acceptable. That can be managed. Also, I can tighten this up a bit. I mean, so this is as high as she's ever going to go. So I could mark this, and I can move this bar down, you know, maybe an inch or so. And I could pick up an inch there, and then I could cut off another inch here. It was all the way down when I did it. So that is nice. That means it'll hit my stops. So let me feel a little slow. I think it's 10 millimeters per second. All right, so I can't set that actuator's position or how far the mast is until I put the forks on, because I want to know how much my forks are going to tick, right? And they're going to be all the way out here. So, I mean, we could lay it out on paper. It wouldn't be an entirely bad idea. I can pick up 1 inch right here. And I would probably offset the hole to the front a bit, because I actually don't want that to rub as a guide, because that's keeping it. I mean, that's not really a guide block, and it's not a bearing surface, and it's taking, like, I wanted those bearings to do their job. I don't want all the force to be on that. That would just introduce a bind and a rub. In order to put the forks on, I need to finish my welding. I can't put that extra weight on with just tacks. So I have to be assured that this is how I want things for that actuator. Also, in order to put the forks on, I need to know the drop of the forks. So I have to finalize my spacing this way. All right, so next step, contemplation.